I'd like to explain how to use substitution to solve a system of linear equations. I have an example that's 2 by 2. For this one, I have 2 equations and 2 variables. I also have an equation or a system that is 3 by 3. For this one, I have 3 equations and 3 variables. These are the steps for solving. You make sure at least one of the equations is solved for x or y. If it's not, then choose an equation that would be easy to rewrite as x equals or y equals. It could be x equals, y equals, or z equals. In the case of the equations or the system that has 3 variables and 3 equations. So pick whichever one's the easiest one to rewrite. Then, and go ahead and do that. Step 2, find the equation that is solved for a variable and circle the expression. So circle what it's equal to. Then step 3, substitute this expression and the other equation. So take the variable out of the other equation and put what the variable is equal to. Step 4, solve the equation. This will give you one of the numbers in the solution. Step 5, substitute the value from step 4 into one of the equations to find the other value. And repeat steps 4 and 5 until all the variables are solved. There are some basic ideas that I want to make clear before we start. And those are your system is named for the number of variables and the number of equations that you have. So we'll write that in. You have to have at least as many equations as you have variables to solve for. That's hard to read, sorry. What else? When you solve for an equation, solve for a variable in step 4. Is it step 4? Solve for a variable. Substitute the value from step 4 into one of the equations. So in step 5, it doesn't matter which equation you substitute into. So say here, I solved for x first. Then when I get my x value, I could put it into either one of these equations and solve for y. It doesn't matter which equation I substitute into. The next or the final big idea I have has to do with your solutions, your answers. You could have a point And that could be an ordered pair, x, y, or an ordered triple, x, y, z. If you have three variables. You could also have no solution. When we graph, you have parallel lines, and these two lines don't share any points. The shared points are the solutions. So if they don't share any points, there's no solution. Algebraically, that looks like an equation that's not true. We'll say 0 equals 1. This is never true. Also, notice there's no variables here at all, just numbers. And there's nothing I can do to make this equation true. When you get an algebraic expression or an equation that is not possible, that's a no solution answer. Also, you could have infinitely many solutions, and graphically, that means that the lines share all their points. Share all points. Because it's two different ways to write the same line. So they graph right on top of each other. Two different representations for the same line. Algebraically, that looks like an equation that's always true. So if you get a funny looking answer, it means either you have no solution or you have infinitely many solutions, or you'll get a point. So let's see what we can do with this example here. 2 by 2, I have one equation that is solved. It's written y equals. So we will circle what y is equal to, and we'll substitute this expression in place of y in the original equation. So I'll rewrite this first equation as negative 3x minus 4, and I will substitute for y. And this is equal to negative 3. When I substitute, I will write the value or the expression from the second equation so I can combine these. Now I have an equation that only has x, so I can use this to find the x value. I'll have negative 3x, and then here I distribute. Negative 4 times 7x is negative 28x. Negative 4 times negative 7 is plus 28, and this is equal to negative 3. I combine these coefficients, the numbers that go with the x's. Negative 3 minus 28 x is negative 31x. This 28, I need to move this constant to the other side so that my variable is on one side and my constants are on the other side. So I will subtract 28 so that I can move it to the other side of the equation. Negative 3 minus 28 is negative 31. So I get negative 31x equals negative 31. And I'm solving for x, so I divide by x's coefficient, negative 31. And I divide on both sides. I get negative 31 over negative 31, that's 1. I get 1x equals negative 31 divided by negative 31 is 1. So x is equal to 1. Now that I know what the value of x is, I can substitute this into one of the equations, one of the original equations. I'm going to substitute into the second one, but you should get the same y value whether you substitute into the first equation or into the second equation. So my second equation changes to y equals 7, and I will substitute for x. Instead of x, I will write 1 because that's x's value. And I find that y is equal to 7 minus 7. So y is equal to 0. So for this system, I found that these two lines cross at a point, and my point is 1, 0. You can graph to check. For my other system, I have 3 variables and 3 equations. It's a 3 by 3. I would start with the equation that's easiest to solve, and I'll number these so that as I'm talking about them, it's clear which equation I'm talking about. So first, well, I need to start with an equation that is solved for x, y, or z. And I do have a y equals equation, but it has x and z in it, and I don't know what x is, and I don't know what z is. So I won't start with this. I also have a z equals equation, and it's equal to negative y, and I don't know what y is. The first equation that would be simple to solve for a variable is equation 1. So I'll start with 1. And I'll solve for z. Negative 5z equals 5. To solve for z, I divide by the coefficient, negative 5, and I get z equals negative 1. I will substitute this into another equation, one of these. I want to substitute into the one that gives me another value soonest. So my plan is substitute into equation 3, and I can solve for y. So equation 3 becomes z equals negative y plus 2, and I said that z is negative 1, so I'll substitute there. Negative 1 equals negative y plus 2. So I subtract 2 so that my variable will be on one side of the equation and my constants will be on the other side. And I get negative y is equal to negative 3. And then I need to change the sign here. So to change the sign, I can multiply times negative 1. I could also divide by negative 1. If I multiply by negative 1, then this changes to y. And if I multiply by negative 1 on the left side, then this is now equal to 3. So I know that z is negative 1, and I know that y is 3. So I can substitute both of these values, this one and this one, substitute into equation 2. Equation 2 is y equals negative 5x plus z minus 6. And I know that y is equation, or sorry, the value is 3. And also, here I have, 3 equals negative 5x. X is the one we don't know. And then plus z, I know what z is. Z is negative 1. So I'll put a negative 1 for z. And this equation has a negative or minus 6. So I substitute for z, and I substitute for y. And now I have an equation that only has x. So now I can find the x value. I'll combine these. Negative 1 minus 6 is negative 7. 3 equals negative 5x minus 7. I'll move the 7 over here with the 3. And I got 10 equals negative 5x, and I divide. So I find that x is equal to negative 2. So I found a value for x and y and z, and I need to write this as an ordered triple. Make sure that you write it in order, x, y, z. My solution is negative 2, 3, negative 1.